Good evening. If you're here, perhaps you're ready to drift somewhere between curiosity and calm, between the quiet hum of the cosmos and the slow rhythm of your own breathing. Tonight, we'll wander together through the Milky Way, our home among the stars. Close your eyes, if you wish. Imagine a soft darkness, stretching endlessly, sprinkled with gentle light, billions of suns, each a whisper from across the ages. Somewhere among them, our tiny world spins quietly, like a drop of dew hanging from a silver thread. The Milky Way is not just a galaxy, it is a vast dream written in light, a story that began long before us and will continue long after we fade into starlight. Its stars are ancient memories. Its dust and gas are the breath of creation itself. And as we drift through its secrets tonight, let each fact be like a lullaby, soft, curious, and infinite. So let's settle in. Let the night wrap around you like a blanket of quiet galaxies. Take a slow breath, and another, and as your thoughts begin to slow, let yourself listen. If you find peace here among the stars, remember to leave a gentle trace of gratitude. Maybe a like, a subscribe, a small echo of your presence in this quiet corner of the universe. Now, let's begin our journey through the Milky Way. The Milky Way feels, at first glance, like a steady address in a restless universe, an old house that has always been here and always will. But if you let your breathing slow and listen carefully to the hush between heartbeats, you can hear a deeper story humming under the floorboards. Our galaxy was not built in calm. It grew from fragments and encounters, from quiet tides and long embraces with smaller companions. Over billions of years, it has gathered what drifted near, unspooling faint dwarf galaxies and weaving their stars into the soft fabric that surrounds us now. Even tonight, threads are being pulled and stitched. Even tonight, edges are moving, almost too slowly to notice. The Sagittarius dwarf galaxy is one such thread. Picture a delicate stream of stars, stretched thin and silver, wrapping around our disk like a shawl that never quite settles. Gravity does not shout, it invites. Bit by gentle bit, Sagittarius is pulled apart, its stars lifted and scattered into lanes that curl across the sky. We are living in the afterglow of an ongoing meal, our home enriched by what once was separate. The way a river is enriched by smaller streams that join and disappear into its flow. Far beyond the horizon of our daily lives, the Andromeda galaxy drifts closer with a patience that feels like eternity. It is already visible to the naked eye as a smudge of ghostly light, and yet it lies more than 2 million light-years away, a quiet lighthouse on the other shore of cosmic night. In about 4.5 billion years, Andromeda and the Milky Way will meet. The word collision suggests chaos, but space is roomy, and stars are solitary travelers. Direct impacts will be rare. Instead, picture a slow ballet. Tidal arms will lengthen and curl like ribbons. Halos will interlace, and supermassive black holes at each center will circle, then sink, then spiral together, beating a rhythm too slow for any living ear. Out of two spirals will rise a new shape, larger, calmer, softly radiant. Not every star that keeps us company was born under our roof. Some are older than the Milky Way itself, ancient wanderers from a time when the universe was young and restless, still practicing how to become galaxies. These halo stars are poor in heavy elements, nearly pure in their simplicity, like candles lit close to the dawn after the Big Bang. They roam in wide, tilted orbits far above the bright road of the disk, taking long, solitary paths through a darkness that remembers them. Their chemistry is a whisper from an earlier world, almost no iron, little calcium, signatures that say, "We were here before your house was built." Astronomers read those signatures the way archivists read faded ink. Every star carries a chemical fingerprint, a pattern of elements that tells where and when it formed, and what kind of stellar fires enriched its cradle. Some stars are heavy with metals, born in crowded neighborhoods thick with the ashes of supernovas. Others are nearly pristine, like snow that has never been stepped on. By sorting these patterns, scientists can group stars into families and trace the invisible strands of old collisions, reconstructing the Milky Way's origin story the way a botanist reads the rings inside a fallen tree. In chemistry, the galaxy keeps its diary. Meanwhile, we are moving swiftly, silently, always. Our solar system orbits the galactic center at more than 828,000 kilometers per hour, over 230 kilometers every second. The numbers feel fierce, but the motion feels like nothing at all, the way a calm lake hides the rush of water below. Even at that speed, one circuit the galactic year takes roughly 225 million Earth years. Since the sun first lit its fire, we have gone around the Milky Way only about 20 times. When the first dinosaurs stretched their necks to taste strange leaves, we were in another neighborhood entirely, peering at a different arrangement of stars, walking under unfamiliar constellations that no human would ever name. Everything moves. The Earth turns, the moon circles, and together we sweep through space, tucked inside the Milky Way's broad, drifting arm. The galaxy is not finished. It still grows. It drinks from the intergalactic medium-thin veils of gas that settle slowly into the disk. It catches small companion galaxies and loosens them into streams. Even darker rivers, currents of invisible matter, thread the halo and help to shape the whole. Some of this nourishment arrives like dew, so soft it hardly leaves a trace. Some arrives with a tug and a tear, braiding our stars with the stars of others. The Milky Way you sleep beneath tonight is not the one your ancestors knew. The galaxy your descendants inherit will be larger, rounder at the edges, stitched from many worlds. From inside the spiral, it is surprisingly hard to count the arms that cradle us. Dust clouds blur the view, and distance makes the far side look like breath on cold glass. Older maps imagined 4 grand arms. Newer surveys suggest a structure more complex, arms that fork and fade, bridges that split and rejoin, clusters that light up like villages in a valley fog. Perhaps the Milky Way is less a neat pinwheel and more a layered swirl, currents and eddies, bright knots where gas is compressed into newborn suns, dim lanes where time asks for patience. Mystery is not an absence here, it is a texture. Every so often, the galaxy breaks its own quiet with a burst of speed. Hypervelocity stars, rare and startling, are flung outward fast enough to escape the Milky Way's embrace. Imagine a tight pair of stars skimming too close to the supermassive black hole at the center. One is swallowed, vanishing into silence. The other is launched like a stone from a sling, sent racing at over 1,000,000 kilometers per hour toward the thin darkness between galaxies. These fugitives travel alone, far from the bright band of the disk, their light a small, steadfast proclamation. Even in a realm ruled by gravity, release is possible. The coming meeting with Andromeda will be grand and slow. On the sky, each galaxy will stretch into long tidal tails, delicate and fierce, like the wing feathers of a bird turning in dusk. Clusters will be torn and remade. Gas clouds will collide, compress, and spark a fresh generation of blue-white stars that burn hot and brief. In time, after many passes and long interludes of drifting, the spirals will settle into one larger shape, perhaps an oval, perhaps something a little softer, its core deepened by the conjoined black holes, its halo broadened by the mingled ghosts of both families. The future of our address is written already in the geometry of their approach, a letter mailed across eons. Not all stars keep to the common flow. In the outskirts and the halo, some move backward, retrograde against the preferred spin of the disk. Their orbits are the footprints of older encounters, evidence of small galaxies captured and dissolved. The Milky Way remembers those meetings in motion rather than in light. To watch these stars is to read the galaxy's muscle memory, a slow choreography that never quite forgets who taught it a step long ago. Over time, the Milky Way has consumed dozens of dwarfs, each a faint lamp carried in from the dark. One of the most significant events, the Gaia-Enceladus merger, happened billions of years ago and stirred our early structure like a spoon in a still pool, lifting stars into wider paths and thickening the inner halo. You can sense these histories in the sky if you know how to look. Cold streams of stars arcing like chalk lines, remnants of instruments that once played their own songs. Our galaxy is not a pristine sculpture. It is a mosaic, a quilt sewn from pieces of other homes. Stellar streams lace the heavens like fine handwriting, legible only when mapped with care. Some wrap around the Milky Way's waist in near circles, others plunge toward the core before rising again. Each stream is a story of tidal forces stretched over time, and together they form a quiet archive of growth. In their thin light, you can see how the Milky Way became itself, by accepting what approached, by making room, by letting gravity do the slow work of blending. Even the shape of the disk tells a tale. The Milky Way is warped, its broad plate bending upward on one side and downward on the other, like a vast record touched by gentle heat. Radio telescopes, listening to hydrogen far beyond the bright stars, trace that wave. The cause may be many hands at once, the pull of satellite galaxies, ripples sent through dark matter, the memory of an old encounter that never quite faded. From a distance, you might think the galaxy is dancing its edges, swaying to a rhythm the night keeps to itself. Under a moonless sky, far from street lamps, you can see a few thousand stars. It feels like drinking from a lake of light. But compared to the Milky Way's full company, hundreds of billions, it is only a drop, roughly 0.00003% of the whole. Most starlight is hidden from naked vision, muffled by distance and dust. That pale river arcing overhead is the bright inner whisper of a structure so immense that our place inside it is more feeling than map. We live submerged in a sea we can barely sense, leaning our heads back to watch a wave brush past. The motion of stars is not clockwork, not the tidy geometry of planets circling a single sun. Closer to the center, where gravity deepens, stars tend to move faster. Farther out, they drift with a more patient pace. Spiral arms are not fixed bridges, but patterns, traffic waves of matter, where stars and gas crowd for a time and then move on. As those density waves pass through, they squeeze clouds into clusters of newborn suns, and for a while the arm shines brighter, curls of blue and white writing a luminous script across the disk. Our sun, too, moves in and out of those patterns, crossing the galaxy's lanes the way a boat crosses slow swells on a quiet sea. Over long spans, the neighborhoods change. Star-forming regions bloom and fade, clusters dissolve, streams blur into the background. If you could compress the Milky Way's life into a single night and speed it up, You would see the arms breathe, the disk ripple, the halo shimmer with faint threads, the core pulse with distant thunder. But for us, held inside the long seconds of human time, it is enough to feel the current beneath us and know it is carrying us on. There is comfort in that knowing. The galaxy evolves, but it does so with grace, changes measured in hundreds of millions of years, transformations that arrive as gently as dawn. The same forces that pull Sagittarius apart also hold our little system close. The same tidal hands that will lace Andromeda and the Milky Way together keep our orbit steady tonight. In this balance of drift and embrace, of scattering and gathering, the Milky Way becomes less a place and more a process, less a landmark and more a lullaby. So when you step outside and the sky is clear, let your eyes adjust until the dust-white ribbon appears. Think of the tiny fraction you can see and the vastness you cannot, the streams and scars and elder stars, the backward travelers and the fugitives, launched from the core, the arms that fork and fade, the warp that sways like a quiet wave. Remember that you are in motion too, Earth turning, moon circling, sun orbiting, all of us folded into a galaxy that is itself wandering through the dark. In that drifting, there is peace. In that change, there is continuity. The Milky Way is never the same from one era to the next, and yet, night after night, it returns, a river of light, to fall asleep beside. The Milky Way holds together because something unseen is holding us. If we only counted what shines: stars, glowing gas, reflective dust, the outer disk should be spinning itself apart, its far edges flung like leaves torn from a whirl, and yet everything stays. The answer is a shadow we cannot touch, dark matter. It doesn't glow, doesn't reflect, doesn't emit, but it weighs on space with a steady hand. There is so much of it that it outweighs the galaxy's visible light by many times, shaping orbits, guiding motion, keeping the disk from unraveling into the night. We don't know what dark matter is made of, but we see its fingerprint everywhere, in the way stars move, in the way the galaxy keeps its shape. It is the invisible scaffolding that lets the Milky Way breathe in place. At the center of this vastness rests a gravity so concentrated it becomes a quiet absence. Sagittarius A*. A supermassive black hole sits there, more than 4 million times the mass of our Sun, tucked into a space smaller than Mercury's path. We can't see the black hole itself, but we can watch the nearby stars loop and whip around it, drawing graceful ellipses through the dark, their speeds a hushed confession that something enormous anchors them. Now and then, wisps of gas drift inward, heat and flare in X-rays, before slipping beyond the event horizon. For the moment, Sagittarius A times slumbers. Long ago it may have thrummed like a quasar, lighting the core from within. Even asleep, it conducts the slow music of the inner galaxy, tugging on orbits with patience older than memory. Around that heart, the Milky Way does not swell into a simple sphere. The central bulge, when mapped, reveals a shape like a three-dimensional peanut or a twisted hourglass, narrow at the ends, fuller in the middle. This geometry likely grew from the galaxy's bar, a dense stripe of stars that turned slowly, buckling over time and puffing upward into this curious form. Gravity is the sculptor. Billions of orbits are the chisel strokes. We live in a spiral galaxy, yes, but its core is a labyrinth of structure, not flat or clean, but layered and alive, like wood grain revealed by careful light. The spiral arms themselves are not just stellar rivers, they are the birthplaces of light. Giant clouds of hydrogen and dust drift through the disk, and as they pass into the denser wave of an arm, gentle pressure gathers them. The clouds compress, gravity deepens, knots form. Inside those cold knots, new stars spark to life. Ultraviolet light from the newborns floods their nursery walls, painting the gas in blues and silvers, outlining soft pillars and rippling shells. The arms glow not because they are permanent bridges, but because star birth moves through them, tracing the galaxy's curls in patterns of creation. Every star, including our sun, once slept in such a cloud, wrapped in darkness until heat and fusion brought a dawn. Beyond the bright, thin disk lies something vaster and more diffuse. The halo, a near-spherical shell of space that surrounds everything we see. It is faint to our eyes but heavy in influence, home to ancient stars, to globular clusters, and to a deep reservoir of dark matter that may hold most of the Milky Way's mass. The halo stars travel on long, slow paths, often far above and below the disk, drifting like lanterns set loose on a black sea. There, the remnants of old mergers linger, as fragile ribbons, tidal streams, and faint shells, where smaller galaxies were pulled apart and smeared across the sky. The halo is the galaxy's outer memory, dim, wide, and quietly in motion, recording what the Milky Way has invited in. Hanging in that halo are over 150 globular clusters, compact spheres, containing hundreds of thousands of stars bound tightly together. They are among the oldest surviving structures in our galactic family, some more than 12 billion years old, their light tinged with the chemistry of a younger universe. Metal poor and enduring, these clusters carry clues about how the Milky Way formed, what it consumed, and what conditions prevailed when stars first began to kindle. Picture golden snow globes of starlight, drifting above and below the disk, each a time capsule that whispers of a colder, simpler dawn. Ancient as it is, the Milky Way is not done growing. It gathers gas from the thin intergalactic medium, the way a wide river draws in mist. It captures small companion galaxies and unwinds them into streams. Invisible currents of dark matter slip through the halo, deepening the well in which stars move. Sometimes this growth is quiet. A cloud falls in and settles, its edges cooling, its atoms joining the wider flow. Sometimes it is disruptive. A dwarf galaxy crosses the threshold and is teased apart, its stars scattered into new paths, its memory kept as a ribbon around the disk. The Milky Way you inhabit tonight is not the one that arched above the dinosaurs. The one your distant descendants will know may be larger still, stitched from the ruins of 1,000 small worlds. In rare moments, the galaxy speaks in sudden speed. Hypervelocity stars, born of close gravitational encounters, shoot outward so fast they can escape the Milky Way altogether. Often, the story begins with a pair of stars wandering too near the central black hole. One falls inward and is lost. The other is flung away like a sling stone, racing into intergalactic night at over 1 million kilometers per hour. These loners leave the plane of the disk, their light dwindling as distance grows, a soft ember carried far from any hearth. In a realm devoted to gravity's embrace, they are proof that release still happens. But the pace of making stars has slowed. Once, in ages long past, the Milky Way burned with a more urgent creativity, collapsing dense clouds into fresh suns at a brisker rate. Now the raw material is thinner, warmer, more widely spread, and some of it is locked behind pressures and fields that resist collapse. Star formation continues quietly, steadily, but the frantic early bloom is gone. We live in the galaxy's gentler middle years, a mature spiral glowing softly, not idle, not finished, simply unhurried. Some of the stars that surround us formed before there was a clean spiral at all. The disk grew over time, flattening as gas cooled and orbits aligned. But older populations survive in the thick disk and in the halo. Stars that kindled when the Milky Way was still a loose cloud collapsing inward. A city not yet paved or planned, their motions and their metal-poor chemistry let astronomers peer backward into the era before order, before arms, before bars, when gravity was still sketching the outlines of home. To feel this timescale, consider the galactic year, the time our sun takes to circle the Milky Way once. It is roughly 225 to 250 million Earth years. In a single orbit, continents drift and crack, oceans rise and fade, creatures appear and vanish, languages bloom and are forgotten. We are thought to be about halfway through our present loop. The last time the solar system passed through this region, Pangaea had only begun to split apart. Dinosaurs had not yet arrived to lift their eyes to unfamiliar stars. In its 4.6 billion years, the sun has completed fewer than 25 such revolutions. For all our speed, nearly 830,000 kilometers per hour, one lap is a patience we can only imagine. Even the way the galaxy spins is a whisper from the unseen. According to the clean lines of Newton's laws, stars farther from the center should move more slowly, as the outer planets do around the Sunday. Instead, in the Milky Way, the outer stars circle almost as fast as the inner ones. The rotation curve stays flat when our intuition says it should fall. Dark matter carries the answer, stretching the mass of the galaxy far beyond where the light fades. With that hidden mass, the equations align. The disk turns like a near-solid wheel, not because we understand every part of it, but because an invisible hand steadies the rim. Scattered through the disk are cold immensities, molecular clouds, vast dark reservoirs of hydrogen molecules laced with dust. Some span hundreds of light years, and some are so dense and chill that they swallow starlight, appearing as black patches against crowded fields. Inside those curtains of shadow, gravity gathers threads into clumps. Inside those clumps, heat and pressure rise and cores ignite. Planets begin as dust motes in these rooms, colliding, sticking, growing in a hush that can last millions of years. The galaxy's future begins here, in silence. When the most massive stars reach the end of their brief, brilliant lives, they go out in supernovae detonations so bright they can blaze brighter than a whole galaxy for a heartbeat of cosmic time. These endings are also beginnings. Their shockwaves travel through the interstellar medium, compressing nearby clouds and nudging them toward collapse. Their ashes, iron, nickel, calcium, gold, scatter into space, seeding the next generation with the elements needed for planets and life. Supernovae are the galaxy's thunderstorms, violent, cleansing, and fertile. Between stars, dust drifts in strands and veils microscopic grains of carbon, silicates, and ice. Invisible light, it hides much of the Milky Way's true work, blotting out nebulae and smudging the fine detail of far fields. But in the infrared, the veil thins. Telescopes tuned to longer wavelengths peer through, revealing nurseries broken open with newborn light. Darkness, it turns out, is often a cradle. The dust doesn't only hide, it helps by absorbing heat, allowing clouds to cool, and protecting tender stages of star birth from harsh radiation. What looks empty can be profoundly busy. Not every reservoir finds a spark. Across the disk, astronomers have mapped massive, cold clouds that remain starless, poised yet postponed. Some are too diffuse to collapse, some are braced by magnetic fields, or churned by turbulence that keeps gravity from drawing them in. These unlit vaults drift on, heavy with hydrogen, rich with possibility. Perhaps they will ignite after a passing shock. Perhaps they'll be torn and recycled elsewhere. In them, the galaxy holds its breath, waiting for the right nudge. Nothing is wasted. The Milky Way recycles matter across generations. Stars live, shine, and shed. Red giants let go of their outer layers. Planetary nebulae release fragile shells. Supernovae expel their cores into the dark. All of this returns to the interstellar medium, where it cools, mixes, and becomes the next cloud, the next star, the next set of planets, the next story. Every atom in your body has moved through this cycle, forged in a star, scattered by a wind or an explosion, gathered again by gravity and time. The galaxy is not a static stage. It is a breathing ecosystem. Metal-poor stars, those with almost nothing heavier than helium, are fossils made of light. They formed early, before many rounds of star birth and death had enriched the universe with heavy elements. We find them mostly in the halo, dim and old. By reading their chemical lines, astronomers step backward into a universe not yet crowded with metals, into an era when the first generations were still teaching the cosmos how to build complexity. Each such star is a window that opens onto the early morning. Stars do not always stay where they are born. Gravitational nudges, resonances with the bar or the spiral pattern, and encounters with clusters and clouds can shift orbits over time. Some stars migrate inward, others outward. Some are scattered above the disk. Some sink closer to the midplane. A few are kicked to great heights or launched toward the halo. Even the sun likely wandered from its natal neighborhood. The galaxy is a city of motion, its residents changing addresses across eons, home a moving target more than a fixed street. There may be a wide galactic habitable zone, a Goldilocks belt where conditions favor life's foothold, far enough from the violent core to avoid too much radiation and chaos, but not so far outward that the ingredients for planets are scarce. In this moderate ring, star density is kinder, metals are available, and the pace is steady. Earth orbits within this mellow lane, a single, quiet home in a vast district where life may have tried, and may yet try again, to bloom. Remember that the spiral arms are patterns more than paths. They move at a different speed than the stars, like a slow wave traveling through a crowd. Stars drift into an arm, shine there for a while, and drift back out, leaving the arm to be lit by younger generations that formed from compressed gas. From afar, the arms look etched. From within, they are a choreography of arrivals and departures, a ripple of density held together by gravity and time. Beyond the light we see, the galaxy hums in other tongues, cosmic rays, charged particles, born in supernovae, and distant engines wash through space and through us, mostly harmless, a faint rain of energy. X-rays and gamma rays shimmer from exploding stars and from the heated edges around black holes. Radio waves whisper from cold hydrogen, from pulsars ticking like clocks, from the breath of distant clouds. The Milky Way is a symphony of frequencies, layered together, most of it inaudible to the naked eye, but no less real. What your eyes receive on a clear night is a sliver of a much richer song. And suspended above and below the core, stretching tens of thousands of light years, are the Fermi bubbles, two vast lobes of gamma-ray glow, discovered only recently. They billow like twin lanterns rising from the center, their edges soft but immense. Their origin remains a mystery written in high energy, perhaps an ancient outburst from Sagittarius A*, perhaps the echo of fierce star formation that once roared through the inner galaxy. Either way, they are silent testaments to a past we can't fully see, luminous scars that remind us the Milky Way has known both quiet and storm. So the galaxy holds, not because it is simple, but because it is balanced by things we can see and things we cannot, by rhythms fast and slow, by births and endings folded into one long drift. Dark matter steadies the rim. A sleeping giant anchors the heart. Bars, bulges, arms, and waves shape the middle distance. Halos and clusters keep the oldest stories safe. Clouds wait. Stars arrive. Stars depart. Dust hides and helps. Shock waves tear and plant. And through it all, we move softly, steadily within a home whose hidden architecture is as tender as it is vast. We don't live in one of the Milky Way's grand highways of light. Our address sits in a quieter lane, the Orion Spur, a slender ribbon set between two great arms, Sagittarius on one side and Perseus on the other. Think of it as a calm inlet between ocean swells, a soft alcove in a cathedral of stars. The Orion Spur is not especially dense and not especially loud. It is ordinary in the gentlest way. Perhaps that ordinariness is what made us possible. In this hush between storms, where supernovae are fewer and radiation is less fierce, Earth had the long quiet it needed for chemistry to stumble into memory, and memory to blossom into thought. From the outskirts, the Milky Way looks dramatic, a bright wheel with a glowing hub and sweeping arms. But in our little spur, the pace is slower. Here, complexity could unfold unhurried, patient, undisturbed enough for life to take risks. Deep toward the center, where the galaxy's heart tightens into gravity and glare, astronomers see an elongated structure, a bar of stars crossing the core like a luminous bridge. In infrared maps, the bar looks like a sturdy spine, turning slowly, redistributing matter across the inner regions. Bars are common in spirals. They arise when stars in the disk drift inward and settle along a central axis, their orbits aligning into a rotating beam that tugs on gas and steers it toward the center. Over time, the bar becomes an engine, feeding fresh material into the core, sparking new star birth along its ends, and, occasionally, delivering gas to the supermassive black hole that waits in the middle. It is not merely a shape, it's a process. The bar sets a rhythm, a quiet metronome, by which the galaxy's inner life keeps time. We are not adrift alone. Our galaxy is part of a loose, gravitationally bound neighborhood called the local group, more than 50 galaxies, most of them small and faint, a few of them grand. The two giants are the Milky Way and Andromeda, each trailed by families of dwarf companions. To the south, the Magellanic Clouds shine like lanterns in Earth's skies, bringing their own stories and streams of gas. Between all these islands of light stretches deep darkness, and yet they share a common fate. The local group spans millions of light years, but distance does not erase the pull. Over ages, the members drift, curve, and slowly gather. Orbits tighten, paths cross. It is a patient archipelago, a family moved less by proximity than by the invisible threads of gravity that bind them. In that family, motion is a long, slow ballet. The tiny dwarfs near the Milky Way spiral inward like moths toward a candle, their stars peeled off into stellar streams as tides unravel them. Other dwarfs wander farther out, lightly tethered, the sway of their path still destined for us. Nothing is perfectly still. The local group breathes. On timescales vaster than life, the group will condense. Galaxies will merge and mellow. What is scattered becomes coherent. What is many becomes one. Look more closely at our home's shape, and you'll notice layering. The Milky Way's disk is not a single sheet, but two interleaved structures, a thin disk and a thick disk. We live in the thin disk, where gas is abundant and star formation is common, where open clusters glitter like handfuls of salt tossed across a dark table. Above and below that plane, the thick disk billows older, puffier, its stars poorer in heavy elements and riding more inclined in elliptical orbits. This stratification tells a history written not in ink, but in motion. The thick disk likely remembers a rougher youth, stirred by early mergers, while the thin disk remembers a long afternoon of steady creation. Think of layers of sediment laid down by different tides, the color, grain, and thickness of each stratum speaking for the era that made it. Threaded through everything, largely unseen, is the Milky Way's magnetic field. On human scales, it's subtle. On galactic scales, it is consequential. It follows the spiral arms, arches into the halo, and loops into filaments that guide dust, shepherd cosmic rays, and influence how gas clouds collapse. Under radio telescopes, the field becomes more than theory. It becomes pattern. Arcs and threads, alignments that polarize starlight and trace invisible highways of influence. The galaxy doesn't only shine, it breathes with magnetism, a hush you can't hear, a structure you can't see with eyes alone, yet one that helps decide where and how the next stars will be born. Between stars is not emptiness, but a restless medium, whisper-thin gas, grains of dust, and streams of plasma, stirred by winds and explosions. The interstellar medium looks blank to the eye, but through radio and infrared it reveals its filigree. Filaments stretching for light years, ripples and shells where supernovae pushed outward, cool pockets where molecular clouds folded down upon themselves. Superbubbles, vast cavities carved by clustered supernovae, open like chimneys through the disk, venting hot gas into the halo, carrying metals into the wider atmosphere of the galaxy. In that constant push and pull, the Milky Way regulates its own pressure, redistributes elements, and maintains a slow, cycling balance the galaxy's weather, measured not in days, but in millions of years. Even now, as you take a breath, cosmic rays thread through you, high-energy particles born in the depths of stars, in shock fronts, in remnants that still glow in radio light. They arrive from every direction, near light speed, guided and tangled by magnetic fields. You do not feel them, you rarely notice. And yet they are the galaxy's silent dispatches, proof that far away something exploded, that energy was loosed into the dark, that the consequences of that flash eventually reached you. The Milky Way speaks in photons our eyes can't see and in particles we can barely catch. It speaks quietly, but always. We often draw the Milky Way as a perfect pinwheel, symmetric and smooth. Reality is more expressive. The disk is lopsided, one side thicker, some arms brighter, the warp of the outer regions tilted and uneven. Star counts differ slightly between hemispheres. These imbalances are not flaws, they are history. The tides of captured dwarfs, the tug of the Magellanic Clouds, the weight of dark matter clumps, each has left a crease, a wrinkle, a twist. A galaxy is not a polished statue. It is a creature, mid-motion, carrying the marks of its past, even as it becomes something new. High in the halo, astronomers have found very old stars, nearly pristine, almost untouched by heavier elements, embers from the universe's first long night. A few may be as old as 13 billion years, older than the Milky Way's thin disk. They shine with a soft, red steadiness, small in mass but huge in meaning. To read their spectra is to open a ledger from the dawn, sparse metals, plain chemistry, a signature from a time when the cosmos had not yet learned to write with a varied palette. They are not just objects, they are evidence, witnesses still speaking. Closer to the center, the wheel turns faster. Gravity deepens toward the core, orbits tighten, periods shrink. A star in the inner regions might loop around the galaxy in only a few million years, while out here in the suburbs, our sun takes hundreds of millions. The disk is not a rigid wheel. It's a fluid dance, where the center leads and the rim lags, where the spiral arms are twisted into gentle arcs by the difference in pace, like cream swirling through dark coffee. Those spiral arms are not fixed bridges of stars. They are density waves, patterns moving through the disk. Gas entering a wave is compressed, clouds collapse, new stars ignite. The youngest, hottest stars make the arms shine, but they don't stay long, drifting out even as fresh light forms behind them. From a distance, the arms look permanent. From within, they are choreography, a ripple that keeps its shape while the dancers come and go. Inside the arms, in the coldest shadows, stars begin as silence. Molecular hydrogen gathers in enormous clouds, chilled to just a few degrees above absolute zero. Under gravity's slow insistence, knots form and densify. The material spins, flattens, and builds a disk around a warming heart. When temperature and pressure cross a threshold, nuclear fusion begins, hydrogen becomes helium, and a star is born. From dark, from hush, from stillness light. Many stars are born together, in clusters bound by mutual gravity. For millions, sometimes billions, of years they travel as families. But the galaxy's tides work on families as they do on cliffs and coasts, gently, steadily. Encounters with other stars tug on members. The cluster stretches and thins. Stars peel away like leaves drifting from a branch. In time, most clusters dissolve, their children indistinguishable from the wider field. Our sun almost certainly began life in such a family. Somewhere in the Milky Way, its siblings shine under different skies, unrecognized, but kin all the same. Among the rarest treasures of the halo are hypermetal poor stars, relics with less than a 10,000th of the sun's iron. They are almost impossibly simple cosmic minimalists forged before many rounds of star death seeded the universe with heavy elements. Each is a lantern from another epoch, illuminating the early chemistry of the cosmos and the first steps toward complexity. Where stars are born, planets tend to follow. Planet formation is not an exception, it is the default consequence of starbirth. After a protostar ignites, a rotating disk of leftover gas and dust remains. Within that disk, grains stick, clump, and grow. Pebbles become boulders, boulders become planetesimals, and the story accelerates from there. Across the Milky Way, planetary systems bloom in countless variations, hot Jupiters brushing their suns, super-Earths hugging dim red dwarfs, icy giants circling far from warmth, compact worlds orbiting in tight clockwork, and solar families not yet imagined. The galaxy holds not just stars, but systems, architectures of weather, geology, and potential. Our sun may also be fortunate in where it rides. It orbits near the co-rotation radius, where the average orbital speed of stars matches the pattern speed of the spiral arms. That resonance means long stretches between crossings of denser arms and the crowded neighborhoods, where supernovae flare more often and gravitational disturbances are common. We drift in a lane where the traffic moves with us. There are fewer sudden shocks here, fewer storms. It is a narrative convenience, perhaps, but a meaningful one, a smoother journey for a fragile world. Even so, our path is not perfectly flat. As the sun orbits, it bobs above and below the galactic plane in a gentle wave up for millions of years, then down, then up again. The cause is the Milky Way's mass tugging in complex ways, producing a vertical oscillation like a cork on long swells. Some have speculated that this motion might correlate with earthly cycles of change. The evidence is mixed, the story incomplete. Still, there is comfort in the image. Even our star sways, even our star dances to the galaxy's soft music. Holding all of this together is a hidden scaffold, dark matter, more massive than everything we can see. It does not glow or reflect. It does not absorb light. Yet its gravity is the quiet boss of our structure. It explains why the Milky Way's outer regions rotate almost as swiftly as the inner ones. Without it, the edges would fly apart like sparks from a grindstone. With it, the equations find their calm. The galaxy we admire in visible light is merely the bright skin wrapped around a deeper, darker body. Most of the Milky Way's mass lies not in the disk, but in an enormous halo of dark matter extending far beyond the farthest bright stars. Sparse old suns and globular clusters drift there like punctuation marks on a blank page, but the page itself is the weight we cannot see. When you think of the Milky Way, you may picture the spiral. That is the face. The body is larger, quieter, and mostly hidden, an embrace you feel but cannot sketch. Even the center, which looks so tame today, whispers of a fiery past. Two giant lobes of gamma-ray light. The Fermi bubbles balloon above and below the core, suggesting that long ago, the black hole at the heart may have flared with quasar-like fury. If so, the Milky Way once wore a crown of brilliant violence, brighter than all its stars combined, a heartbeat we missed by billions of years, but whose echo is still legible in the sky. Galaxies do not stop becoming. Bars can form and dissolve. Arms stretch and fade. Gas flows inward. Winds and supernovae push it outward. The disk warps and wobbles. The halo absorbs and remembers. A galaxy is a verb disguised as a noun. Its beauty is less about symmetry than about grace and motion. Across that motion, the fabric of space carries ripples from far beyond, gravitational waves launched by merging black holes and colliding neutron stars. Those ripples pass through the Milky Way and through us, lengthening and shortening distances by unimaginably tiny amounts. We do not feel them in our bones, but our instruments do, in their lasers and mirrors. It means the whole universe participates in one conversation, matter moving there, space-time moving here, the message traveling everywhere. Not every star obeys the main plane. Some trace tilted, elongated orbits, looping far above and below the disk. Many began life elsewhere, born in dwarf galaxies that the Milky Way later absorbed. Their paths are scars cross-hatched into our gravitational field, maps of collision and assimilation, memory encoded not in light, but in motion. Throughout this, Neutrinos, ghostly particles with almost no mass, stream in trillions through every square centimeter of your body each second. They come from the sun's core, from supernovae, from cosmic rays slamming into atoms high in the atmosphere. They slip through planets and people, rarely interacting. We build detectors under mountains and ice to see a handful flash. In their quiet way, neutrinos let us eavesdrop on places we cannot otherwise touch. The interstellar medium, for all its quiet, is turbulent. Flows collide, eddies form, magnetic fields twist gas into ropes and sheets. Temperatures span from icy darkness to million-degree plasmas. This turbulence helps set the sizes and masses of stars, regulates the timing of collapse, and shapes the distribution of matter across the disk. What looks serene from afar is, up close, a slow storm, an ocean rolling in measures of centuries and millennia, rather than minutes. Not all worlds keep company with a star. Some are rogue planets, ejected during chaotic youth or born in isolation, traveling the galaxy without a dawn. Billions may wander, cold and black, warmed only by internal heat. They are reminders that the Milky Way holds more stories than those we can light up. Travelers without sunsets, pilgrims without skies. Even dust, tiny grains of carbon and silicate, listens to magnetic fields. The grains spin, they align, they glow faintly at microwave wavelengths. They polarize starlight and reveal the orientation of invisible lines. Many carry complex organic molecules, polycyclic, aromatic hydrocarbons and other carbon-rich compounds, the simple chemistry that points toward life. Dust rides on galactic winds and settles into star-forming clouds. It gathers in disks where planets begin. It is not refuse, it is seed. The birthplaces of stars are often birthplaces of worlds, and with them, the ingredients of life. Nebulae rich in water, carbon compounds, and other prebiotic building blocks feed young systems with what they need to attempt biology. We don't yet know how often those attempts succeed, but the conditions arise naturally and often. Long before life wakes, the recipe circulates through the Milky Way, dispersed in ice on comets, tucked into pebbles, hidden in dust. Some stars spin with breathtaking speed, whirling in hours rather than days, their equators bulging and their light flaring blue. Others turn slowly, red and placid, taking their time. Some burn brilliant and brief, others simmer for eons. Diversity is the galaxy's most honest word. No two systems are quite the same. No two histories align perfectly. The Milky Way's signature is variation, and variation is the mother of possibility. From our vantage, the galaxy leans across the sky. The plane of the Milky Way is tilted roughly 60 degrees relative to the ecliptic, the path the sun and planets follow. That lean is why the bright river of the Milky Way rises at an angle and changes its pose with the seasons. We are not aligned with the city we inhabit. We're sailing through it on a slightly skewed course, a small, tilted boat crossing a larger, rotating sea. At the edge of vision and beyond, white dwarfs, ancient stellar remnants, drift in the halo, older than the thin disk itself. Farther still, the farthest stars orbit well beyond the recognizable spiral, moving so slowly that one loop takes billions of years. Many were captured in mergers long past. Now, they are sentinels, marking the Milky Way's true reach. They show us that our home extends far into darkness, defined not by brightness, but by gravity's hold. When you look up on a clear night, know this: you see very little of all that is there. Dust hides, distance dims, darkness dominates, And yet, perhaps that partial view is a gift. It lets imagination fill the gaps with questions, and questions are threads that pull us deeper into understanding. The Milky Way is not just what is revealed, it is what is suspected, inferred, hypothesized, and patiently tested. It contains bright certainty and hushed mystery in a single, breathing whole. We cannot step outside to take a portrait from above. We live inside the forest, looking along the trunks. For centuries, astronomers mapped by counting stars, measuring distances, and piecing together perspectives from every wavelength we could build instruments to see. The picture is sharper now, thanks to missions that chart billions of stars with exquisite precision, but the humility remains. Our map is always a work in progress. And in that work, instruments like Gaia redraw our understanding. By tracking positions and motions of stars across the entire sky, Gaia reveals structure where once we saw blur. The warp of the disk, the streams of shredded dwarfs, the subtle curls in the halo, the very breathing of the galaxy. Each new data release adds depth to the map and motion to the story, turning the Milky Way from a flat diagram into a living, three-dimensional timepiece. Through the disk runs the galactic plane, a dense, star-rich corridor. When you stand beneath a dark sky and see the hazy band arcing overhead, you are looking along that plane through crowded neighborhoods, dust-choked nurseries, and overlapping swarms of suns. The region toward Sagittarius, the direction of the center, appears thicker, brighter, and more complex. Even with naked eyes, you feel the weight of numbers there, a glow that is not one star, but the sum of billions. Closer analysis shows that radio waves sift through dust where visible light cannot, tracing neutral hydrogen that outlines spiral arms, highlighting supernova remnants, and revealing pulsars whose beams sweep space with metronomic precision. Pulsars serve as cosmic clocks, so stable that their timing can test gravity and help us search for gravitational waves across galaxy-wide baselines. In the quiet between stars, order persists. A neutron star can tick in the dark like a wristwatch that will not fail. We live in a galaxy that recycles its matter. Stars form, shine, and shed. Supernovae enrich the medium with heavy elements. Dust and gas gather again, cooled by their own shadows, and new stars ignite. Matter moves from light to darkness and back again, not once, but forever. Your bones carry calcium from a red giant's breath. The iron in your blood was forged in a star that died. The oxygen you inhale was cast off by suns long gone. You are not merely in the Milky Way, you are of it. And always, the Milky Way breathes. Gas rises from the plane in fountains, powered by clustered supernovae, cools in the halo, and rains back down over tens of millions of years. Superbubbles vent energy through tall chimneys, balancing pressure, spreading metals, shaping the halo's faint glow. Inflows from the cosmic web replenish the reservoir, cold filaments and hot streams, delivering fresh material for future stars. The galaxy is not a closed jar. It is a node in a larger circulation, drinking and exhaling, sustained by threads spun in the early universe. Some orbits are not polite circles. Elongated, tilted paths carry stars high above and deep below the disk, marking the residue of past encounters. Tidal forces from the Milky Way's mass stretch clusters and satellites into filaments that lace the halo arcs, ripples, shells. Unraveling is not destruction, it is incorporation. The strands become part of us, stitched into our motion, their origins still traceable in chemistry and trajectory, like accents in a shared language. We measure distance with light that beats Cepheids and RR Lyrae stars, whose pulsation periods reveal their true brightness. Compare intrinsic to apparent, and distance falls out of the math. With these yardsticks, astronomers ladder outward, mapping the Milky Way's thickness, its tilt, the warp's amplitude, the span of the halo. Variable stars are the lights that measure the dark, reliable heartbeats scattered across the spiral. Even our mass is a question still being answered. Estimates place the Milky Way around 1 trillion solar masses, perhaps more, much of it dark matter. Some evidence hints we may be as heavy or heavier than Andromeda, despite appearing slightly smaller and fainter in starlight. The answer matters, because the future collision between our galaxies will be shaped by exactly how much gravity each brings to the meeting. For now, we live with uncertainty in the numbers and confidence in the trend. Most of our mass is hidden. The Magellanic Clouds add their own complications. Newcomers, perhaps on their first deep approach, dragging the Magellanic Stream, a ribbon of hydrogen behind them. The stream may someday feed star formation in our disk, or settle into the halo, an heirloom passed down from satellite to host. Their arrival has likely tugged our outer disk into a more pronounced warp, a reminder that even distant companions can rock the boat. Not all gas obeys the main plane. Some clouds and even stellar groups follow polar orbits, moving nearly perpendicular to the disk. These paths, odd at first glance, make sense in the language of history. Captured dwarfs, misaligned infall, the leftovers of a more chaotic past. The Milky Way does not impose a single geometry. It absorbs many and lets gravity's patient averaging knit them into coherence. In the densest places cluster cores, where stars are packed, stellar collisions can occur. Rare, yes, but not impossible. Two suns meet, merge, and emerge as a blue straggler younger looking than its peers, as if time briefly ran backward. Gravity writes unusual biographies in crowded neighborhoods. Binary stars pairs, bound in mutual orbit, are common, but even their bonds can be broken. A close pass by the central black hole can tear a binary apart, capturing one star and flinging the other outward at hypervelocity, perhaps fast enough to leave the galaxy behind. Sometimes supernovae and tight binaries kick survivors onto escape trajectories. To watch such a star is to watch exile in slow motion, a traveler carrying our galaxy's memory into the dark between galaxies. The Milky Way's dust carries organics. Its clouds seed new systems with water, carbon, alcohols, sugars. Chemistry blossoms at the edges of starlight. With each generation of stars, the recipe grows richer, and with each recycled cloud, worlds inherit a deeper pantry. Life might be rare, the ingredients are not. From Earth, the Milky Way appears edge-on, a luminous river curving with the horizon. We stand inside and look along the grain, the way one peers through a forest, seeing corridors of trunks rather than the canopy's design. That perspective is limited, but it is intimate. We do not just observe the galaxy, we travel inside it, our bodies made of its ashes, our breath stirred by its cycles, our history guided by its calm spur and generous quiet. And so the story here on this minor lane, in this soft pocket between the great arms, continues. Stars form and fade, clusters gather and scatter, streams lengthen and curve. The bar turns, the disk ripples, the halo hums, dark matter weighs without shining. Magnetic fields thread through dust like piano wires through velvet. Neutrinos pass through us unnoticed, while pulsars keep time for a future we are just learning to hear. The Milky Way is not a still picture. It is a long exhale, a slow tide, a patient loom weaving brilliance from darkness and returning darkness to brilliance again. The Orion Spur's quiet doesn't mean absence, it means room. Room for dust to cool and settle into veils. Room for clouds to collect without being torn apart. Room for orbits to unfold in long, unhurried curves. In this margin between grand arms, radiation storms are fewer, and supernova shock fronts arrive less often. Quiet does not erase risk, but it dilutes it, like rainwater mellowing the salt of a tide pool. Within that diluted danger, molecules had time to link and unlink, to practice being patterns that could remember, correct, and persist. The galaxy's calm corners are not accidents. They are conditioned, softly drawn frames inside which complexity can bloom. Down the long corridor of the disk, the bar keeps turning slow as a century hand on a cosmic clock. Its ends curl into the inner spiral arms, lanes where gas is shepherded and stars ignite in clustered batches. In those luminous nurseries, ultraviolet light sculpts the clouds into pillars and shells, and newborn winds carve hollows where the next generation will gather. The bar is not just a bridge. It is a conveyor, a mover of matter from the outskirts toward the center, a rhythm that steadies the inflow so that the core can breathe without choking. If you could listen in wavelengths your ears were never meant to hear, you would notice a pacing there, a measured hush, hush, hush of orbits aligning and unaligning, guiding the galaxy's inner weather. Far beyond, the local group's small companions keep telling their stories. Some are ultra-faint dwarfs, barely more than handfuls of stars, held together by halos of dark matter. To our eyes, they are nearly invisible, but their motions are eloquent. They loop and bow, pluck at the Milky Way's outer disk, and bequeath streams to the halo as they are gently unwound. Others, like the Magellanic Clouds, are more robust storm lanterns that sway, trailing the long ribbon of the Magellanic Stream behind them. The stream is not simply loss, it is provision. Its gas, stretched thin by tides, may settle into the halo, cool along magnetic corridors, and fall as rain onto the outer disk, where it will be folded into new clouds, new stars, new worlds. In this way, even what is stripped away becomes gift. Between the thin and thick disks lies not a seam but a gradient, kinematics, shifting, chemistry, tilting, orbits bending from flat to puffed, from circular to oval. The thick disk remembers heat, jostle, and early mergers, while the thin disk remembers patience and replenishment. If you could slice the Milky Way like a cake and count its layers, you'd find not uniform bands, but marbling swirls where histories met and blended, where an old stream kept its accent while learning the new city's streets. Magnetic fields do not shout, they suggest. Dust grains, tiny and stubborn, align with these fields and polarize the light that slips past, leaving faint signatures we can read. Radio maps show arcs and loops, radio spurs that rise above the plane, perhaps the walls of ancient superbubbles or the stretched skins of magnetic chimneys. In some places, dust spins fast enough to give off a faint microwave glow. In others, it merely points, like iron filings, arranging themselves to reveal a pattern you couldn't otherwise see. Through magnetism, the invisible sketches, the outlines of the unseen. The interstellar medium, so thin you could fly a starship through it and never notice, is nevertheless a sculptor. Shock fronts ripple outward from supernovae, piling gas into ridges that later sag into filaments. Stellar winds from massive stars sweep out cavities, the edges of which knit into dense walls where gravity can take hold. Hot gas escapes into the halo through broken places in the disk, then cools and drifts down in a gentle rain that reddens the plane with metals. Each process tugs on others. The medium is not a backdrop. It is the fabric on which every tale of star, birth, and death is stitched. Cosmic rays, for all their energy, are listeners too. Magnetic fields snare and redirect them. Shock waves accelerate them. Clouds slow and scatter them. When they strike atoms high in Earth's atmosphere, they produce brief, bright cascades of particles, a sky of invisible fireworks that our instruments catch as faint pinpricks of knowing. In those pinpricks are stories about the engines that flung them. Supernova remnants with their expanding rings. Pulsar wind nebulae with their electric hearts. Perhaps even black hole jets from times and places we can barely guess. If the Milky Way were a person, its asymmetries would be the set of its shoulders, the slant of its gaze, the way its stride remembers a hill climbed long ago. One side of the disk is a little thicker. One arm stretches farther before fading. The warp leans more on one edge than the other. These are not flaws, but biographies, natural, specific, unrepeatable. The galaxy's portrait is not airbrushed symmetry, but lived-in grace. Among the halo's elders, the metal-poor stars are libraries. Their surfaces carry records of the elements available when they formed. Some bear the subtle fingerprints of kilonovae, those rare collisions of neutron stars that forge the heaviest elements, the auric dust of gold, the hush of platinum, the purple weight of uranium, and fling them into space. When a later generation forms in a cloud laced with such ashes, its stars carry faint enrichments that betray the violence that fed them. Read enough spectra, and you can reconstruct a banquet menu of ancient detonations. Near the core, orbits hustle. Stars there write tiny, fast loops, responding to the concentrated mass of the inner bulge and the supermassive black hole. Further out, the loops broaden and slow, but they never stop. This differential rotation twists the arms and keeps the disk from acting like a solid plate. It also means that the map of the Milky Way is a moving map coordinates that change with time, neighborhoods that drift, addresses that blur. Cartography here includes not just position, but velocity and history. The arms, being waves of density, encourage and then release. Gas enters, pressure rises, clouds collapse. Stars ignite and illuminate the scene, then drift onward, aging into quieter colors as the wave moves on. Young stars make the arm look bright. Older stars lag in subtler tones. The arm seems permanent because it keeps being relit by the newborn. It is the galaxy's way of writing motion so smoothly that the eye believes it is form. Deep in the cold, a protostar stirs, its disk dark, thin, and vast, collects pebbles in lanes where gas slows and pressure builds. Pebbles grow into planetesimals, planetesimals into protoplanets, their gravity gathering debris until orbits begin to clear. Close in, rocky worlds accrete. Farther out, icy cores swell and snag gas to become giants. Beyond them, a scatter of ice and stone waits like a long memory at the edge of a solar system's reach. This architecture, vague in details but faithful in outline, plays out everywhere. Variety arises from timing, mass, temperature, and chance, but the grammar is shared. Clusters often leave fossil traces when they dissolve. A subtle coherence in motion and chemistry among stars spread across the sky. With instruments that measure not just where a star is, but how it drifts and what it's made of, those traces can be recovered. We call them moving groups, families that lost their house but kept their heartbeat. Somewhere among them, perhaps, are the sun's scattered siblings, their spectra rhyming with ours, their paths whispering, "We were born together once." Hypermetal-poor stars don't merely look old, they are old. Their scarcity of heavy elements tells you they formed before the universe had been much enriched by supernovae. Some show peculiar ratios, a sign that a single, early supernova's ashes dominated their birth cloud. In this way, one star can be the footnote to another star's explosion across billions of years. Planets come in families that expand what planet can be. Lava worlds that bake under relentless light. Ocean worlds with pressures that crush. Ice giants with layered atmospheres that run electrical storms. Tidally locked rocks, half day and half night forever. Gas giants close enough to blush. Some families are compact, their members orbiting in days. Others sprawl, taking centuries to stroll once around their suns. If you could visit even a handful, you'd bring back new words, because old ones would not fit. The co-rotation radius is less a line on a map than a truce. Here, the pattern speed of the arms and the average orbital speed of stars agree, and so crossings are rarer. We glide beside the wave rather than through it, enjoying long spells of open road. Resonances in a galaxy are like soft harbors, places where motions match enough to lower the friction of experience. That lower friction may have been kindness we never knew to ask for. Our sun's vertical oscillation, its bobbing through the plane, is a reminder that orbits in galaxies are braids, not circles. There is radial motion, in and out, azimuthal motion, around, and vertical motion, above and below. Combine them, and you get a loop that sways like a calligrapher's stroke, steady, graceful, repeating with variation. To live inside that stroke is to be part of a writing you can't read all at once. Dark matter remains the polite mystery that makes everything else make sense. Candidates abound in theory. Detection remains elusive. Yet the curves of rotation, the binding of clusters, the growth of structure on large scales all insist that something heavy and dark is there. If visible matter is the melody, dark matter is the key signature, silent, but shaping every note you hear. That key signature swells into the halo, extending the Milky Way's reach far beyond its light. There, the stellar density thins to whispers, globular clusters tight. Ancient cities of stars swing in wide orbits, their cores crystalline with gravity's patience. Streams ribbon through, some named for the constellations they pass, others for the surveys that revealed them. The halo is subtle geography, hard to see, easier to infer, full of landmarks that move. Long after the central black hole's brightest days, the Fermi bubbles still rise like thought balloons from the core. They are the long memory of an old outburst, evidence that even quiet hearts have had their thunder. If you could see in gamma rays, the Milky Way would wear these lobes like a crown, soft-edged but enormous, testifying to a time when the center pressed its hand more forcefully against the sky. Galactic evolution is punctuated. Slow flows and gentle drifts occupy the long stretches. Then a merger arrives and the tempo shifts. Bars strengthen, disks thicken, star formation flares, then ebbs. Afterward, a new normal unfolds. The beauty lies in the alternation, the way tranquility and upheaval trade places, so that the galaxy can both build and rebuild, accumulate and reconsider. Gravitational waves, faint as they are by the time they reach us, add a soundtrack too subtle for ears, a deep, persistent murmur from mergers scattered across space and time. Arrays that time pulsars across the sky can, in principle, feel this background as tiny departures from perfect rhythms. When they do, the Milky Way becomes not just a listener, but a sensor, its own population of neutron star metronomes, acting together as an instrument the size of a galaxy. Stars on inclined orbits sketch the Milky Way's three-dimensional structure, like inked threads crossing a loom. Their paths help us weigh the mass we cannot see, to sense how the halo is shaped, to determine whether its density falls off like a smooth sphere or is clumped like a cloud bank. You can't touch dark matter, but you can watch what it does to the choreography. Neutrinos bring news from inside stars, places opaque to light. In supernovae, a deluge of neutrinos arrives before the electromagnetic fireworks, telling us that a core has collapsed and that an explosion is about to bloom. In quieter times, solar neutrinos whisper of fusion's steady hum. To catch even a few, we build great vats under mountains and ice, where the quiet is quiet enough that a single faint flash becomes a story. The interstellar medium's turbulence changes scale like a fractal coastline, filaments within filaments, knots within knots, each shape affecting the next. Gravity finds footholds along these structures. Magnetic fields lay tracks. Chemistry takes opportunities where currents eddy into calm. Over millions of years, such detail accumulates into difference. Two neighboring clouds with similar masses can produce very different clusters simply because their internal weather was different. The galaxy is sensitive to texture. Rogue planets drift without sunrise or sunset. Some wear thin atmospheres over frozen seas. Some keep warm from radioactive decay deep within. Some may hide oceans under ice, currents moving slow as continents, cycling nutrients in the dark. If life can take root in such places, it would be the slowest of patient arts, a metabolism measured in geological size. The Milky Way holds space for that kind of experiment too. Dust grains, which seem like trivia beside stars, are alchemists. On their surfaces, atoms meet and combine hydrogen, finding hydrogen to become molecular, oxygen slipping into the mix to seed water. Ultraviolet light both breaks bonds and drives new ones. In this balance, complexity ratchets upward not by leaps but by increments, each increment a small remembering of what worked. Prebiotic chemistry in star-forming clouds delivers ingredients into disks, comets, and worlds. Carbon chains lengthen, rings close, radicals wander, and leave partners behind. When a planet forms in such a neighborhood, it inherits not just rock and ice, but recipes, directions, written in the ratios of elements and the presence of particular molecules. Whether those recipes are followed depends on conditions and contingency, but they arrive in the pantry all the same. The fastest spinners among stars blur at their equators, their atmospheres fanned into disks by centrifugal force, their spectra sing with lines broadened by speed. In their youth, they fling matter outward in fits and filaments. They are extremes that test models and stretch definitions the way all extremes do. They remind us that star is not a single kind of thing, but a family name worn by individuals with habits all their own. Because the Milky Way's plane is tilted relative to our ecliptic, the galaxy changes its posture in our night sky with the seasons. At certain months and latitudes, the center climbs higher and the river looks denser. In others, the band lies lower and thinner. For millennia, humans have used this seasonal tilt as a clock and compass, measuring not only hours, but belonging, knowing when the river of light would return to its highest arch. White dwarfs cooling in the halo are embers that refuse to go out. Their light is faint but precise, their temperatures falling according to predictable physics. A population of such remnants can serve as a chronometer for ancient episodes, helping us estimate when certain waves of star formation crested and broke. They are what remain when a small star's story is finished, a precise period at the end of a long, fluent sentence. The farthest bound stars, barely held, outline the Milky Way's true jurisdiction. Their orbits, stretched thin by distance, take so long that no single lifetime can watch one complete loop. Yet from their motions we infer how the halo's mass is spread, where the influence thins toward intergalactic space, how the edge is more a fade-out than a cliff. Radio surveys peel back dust's curtain to reveal the skeleton, long lanes of neutral hydrogen, known by the quiet 21-centimeter line, clouds of carbon monoxide, marking denser regions where molecules thrive, supernova remnants, outlined as rings and arcs, where optical maps show fog, radio maps show grain the wood beneath the varnish. Together, they make the picture honest. Pulsars, with their lighthouse beams, allow us to weigh the unseen. When a pulsar orbits another compact object, tiny shifts in its timing betray the mass that tugs on it. When many pulsars' timing is compared over years, the faint background of gravitational waves might gently dimple the schedule. In this way, the Milky Way becomes a listening device, eavesdropping on the universe's deepest murmurs. Galactic fountains rise, where clustered supernovae combine their breath. Hot gas punches upward, metals ride along, magnetic field lines stretch like elastic and then relax. The flow cools and descends, feeding the disk in ragged, gentle rain. Between the plane and the halo, this circulation acts as the galaxy's respiration, a slow in and out that stabilizes pressure and spreads nutrients. Streams in the halo weave a lace so delicate you could miss it if you blinked with the wrong instrument. Each is a remnant of a merger or a cluster being gradually pulled apart, a long, thin line of stars moving together through a space that otherwise looks empty. To follow a stream is to follow time in reverse, tracing a path back to a parent that may no longer exist. Tidal forces from the Milky Way do not crack things like a whip, they unravel them. A dwarf galaxy drawn close is stretched, its outer stars peeling first, its core persisting longest. Clusters fare the same in miniature stars, leaving in ones and twos along narrow escapes. What seems like breaking is often translation, a small system becoming part of a larger one, its identity flickering into a wider field. Cepheids and RR Lyrae pulse with predictable grace, turning their expansions and contractions into yardsticks. Their periods tell their true brightness tells their distance. Stack such measurements across the sky, and you build a scaffold from which the galaxy's shape can be hung, not as a guess, but as a measurement, politely repeated until doubt becomes small. Weighing the Milky Way is an exercise in patience and inference. Outer halo stars are scarce and shy. Their velocities are tricky. Substructure complicates averages. Yet every new catalog lengthens the lever arm of our understanding, adds satellite motions, stream dynamics, and the behavior of globular clusters, and the range of plausible masses tightens. We do not yet know the precise number, but we know the story: a spiral, wrapped in a vast, dark cloak. Whether our cloak is heavier or lighter than Andromeda's is more than bragging rights. It shapes how the eventual encounter will unspool, how quickly the first pass slows both disks, how strongly tidal tails will fling stars into space, how the merged core will settle. For now, the balance is close enough that humility is the only sensible posture. Two great spirals approach, and the future will be composed by their combined weight. The Magellanic Cloud's likely first deep pass is a fresh wind in our outskirts. Their wake has stirred the outer disk, brightening the warp, perhaps lighting up new star formation where the stream's gas brushes the plane. They remind us that new arrivals can change old habits, that even a giant can be nudged into a new gate by companions it only recently met. Gas on polar orbits, inherited from misaligned infall or captured companions, acts as a truth serum for the galaxy's potential. If the halo were perfectly spherical, certain precessions would vanish. If flattened or triaxial, other wobbles appear. Watching such gas drift is like watching a tossed coin wobble on a table. The shape of the surface speaks through the wobble. The galaxy keeps old fireworks in shells, vast spheres, where a cluster's combined energy pushed outward long ago. Over time, those shells fragment and seed their perimeters with new stars. Today they are ghostly bubbles. Tomorrow they are scaffolds on which the next luminous neighborhoods will be hung. In the cores of globular clusters, where stars pass close enough to exchange momentum, collisions and near collisions can exhume oddities: blue stragglers brighter than they should be, exotic binaries that conspire to turn gravity into drama, millisecond pulsars spun up by accretion. Dense places breed unusual outcomes. The Milky Way carries entire laboratories of such exceptions in orbits that swing from the deep halo toward the heart and back again. Torn binaries at the center give us projectiles, hypervelocity stars that carry the galaxy's goodbye out into intergalactic night. Some will slow and return, captured by the broader gravitational field of the local group. Others will keep going, long after the last light from their birthplace falls behind. The idea that a single star can live the rest of its life between galaxies changes how distance feels, not as emptiness, but as residence writ large. The dust that muddies our optical view grants us insight elsewhere. In infrared, hot stars vanish and warm dust glows. In submillimeter light, cold clouds blaze. In X-rays, the edges of violent places sharpen. Each wavelength is a dialect. To understand the Milky Way, you have to be multilingual, fluent in spectrums the eye never evolved to see. We see the galaxy edge on, and so the galactic plane becomes a road we stand upon, looking both ways. Towards Sagittarius, the crowding grows. Towards Cygnus and Scutum, the lanes richen with nebulae and clusters. Along the plane, dark clouds scrawl their calligraphy over fields of stars, and bright knots mark where massive clusters have recently come of age. If you've ever watched the Milky Way rise from a truly dark place, you know the sensation, not of seeing an object, but of recognizing a context, the background against which the smaller details of living make sense. The galaxy recycles not only elements, but also momentum. Winds and blasts accelerate some matter while breaking others. Inflows and outflows share angular momentum like dancers trading steps. Star formation turns random gas into ordered systems. Supernovae turn ordered systems back into random gas. Between those two poles, order and disorder, the Milky Way sustains a dynamic balance, neither collapsing into stasis nor fraying into chaos. From the Orion Spur, the city's center is distant, but its influence reaches us in waves. Density waves in the arms, magnetic waves rising in arcs, and the faint whisper of gravitational waves that have nothing to do with us and everything to do with the universe at large. We are small, but we are connected by lines that stretch through the disk, into the halo, across the local group, and out to clusters and voids beyond. Every quiet night on Earth is threaded with motions that began long before life could notice. The sun's siblings, if we find more of them, will tell us not only where we came from, but also how we came, what the chemistry of our birth cloud was like, which nearby supernovae salted it, how crowded our nursery stood. Already, candidates appear stars that share our particular blend of elements and drift in ways that make sense for kin. When we piece those clues together, home will grow a second definition, not just a spur in a spiral, but a cradle in a cloud that no longer exists. Meanwhile, variable stars keep time, pulsars keep better time, and the galaxy as a whole keeps the longest time, the measure of orbits and drifts, of bars forming and relaxing, of arms leaning and loosening. Inside that time, lives fit like notes in a symphony, short, bright, and necessary, not for their endurance, but for their placement. If you listen closely, the rhythm is restful. Even change arrives in measures, not shocks. We will not see the Milky Way's final shape, because there is none. It is a becoming that outlasts every watcher, a conversation between gravity and light, moderated by dust and wind. Our contribution is perspective and care, to map with patience, to infer with humility, to translate the galaxy's many languages into understandings we can share. In that work, we become part of what the Milky Way does. We measure, we remember, and in remembering, we add another kind of order to the dark. The Orion Spur remains our soft harbor. It is not the brightest address, nor the most decorated, but it is sturdy and kind. In its slower lanes, the Earth could orbit long enough for oceans to learn tides, for continents to wander and seed mountains, for lungs to rise and fall, while eyes grew brave enough to look outward. The spur is not a footnote, it is a setting, a quiet stage that made this telling possible. And so the galaxy continues, magnetic fields threading dust, dust carrying organics, organics riding comets into young worlds, worlds circling stars within a tilted disk, stars taking shape in the arms and dispersing into the field, clusters dissolving, streams lengthening, the bar turning, the halo holding, the dark matter halo steadying all. Cosmic rays rain, neutrinos pass, radio lines murmur, X-rays hiss, gamma rays bloom, where power concentrates. Every wavelength is a vein in the same living leaf. What we cannot see, we infer. What we cannot infer, we patiently approach. The Milky Way rewards that patience, not with certainties alone, but with textures, curves in a rotation plot, ripples in a stellar stream, kinks in a magnetic arc, faint bubbles rising from the core. Textures are how truth appears when grandeur is too large to hold all at once. From our neighborhood's quiet, we feel safe enough to wonder, and wonder itself becomes a kind of instrument, sensitive to pattern, tuned to awe. The galaxy does not require our amazement to be what it is, but amazement fits us to it, prepares us to read and to rest. In the hush between the Sagittarius and Perseus arms, we learn the sound of a long breath, the weight of a patient tide, the comfort of a home that is not a house but a motion shared. The Milky Way keeps turning, we keep orbiting. The Orion spur will carry us forward, steady as a lullaby, past dust lanes and nebulae, past clustered beacons and silent fields, under the warp's gentle rise and fall. Along the way, the galaxy will keep doing what it does best, making time visible in streams and shells, in pulses and winds, in lights that blink and lights that do not blink at all. And we, brief and bright, will keep doing what we do best, noticing, naming, and falling gently, gratefully, to sleep within it. And now, as the story quiets, the Milky Way stretches across the night, a soft river of light flowing through eternity. Its arms turn in silence, its stars breathe in rhythms older than memory. Somewhere within that luminous tide, we drift one small world, turning, listening. All that we see, the spirals, the dust, the gentle arcs of starlight, is only a surface, a faint whisper of what truly is. Beneath the glow lies motion, gravity, time itself, weaving endless threads through darkness. Every atom in our bodies, every breath we take, was once part of this great galactic sea. The iron in our blood, the calcium in our bones, they were born in the hearts of ancient stars that lived, burned, and gave themselves back to the void. So when you look up tonight, remember, you are not beneath the stars. You are within them. You belong to this turning, this shining, this slow and sacred dance of matter becoming light. The galaxy is not far away. It hums inside you, a quiet rhythm that began before words and will continue long after. Let your thoughts drift now, as the stars do softly, slowly, without hurry. Let the music of space fade into a hush. The Milky Way turns on, calm and infinite, and you, a flicker within its glow, can rest, knowing that even as you sleep, the universe keeps its gentle time. Good night, traveler of starlight. The galaxy watches over you.